Yes.
Okay. I've got the HP scope hooked up to the BK. I'm using the external trigger hooked up to the horizontal input to scope. This is a post marker injection. That's a 10.7 megahertz marker. As you can see, I can turn it up and turn it down, keep it down so it doesn't distort anything. And I'm feeding it the 10.7 here. Sweep, wet, sweep. I think I got it maxed out. Let's see. Okay, there's maxed out sweep. And you can see where the marker shows up on the scope. It's down here on the base of this marker. This is currently the way I have the IF tuned. I'm going to retune it, but what I want you to note is I'm at the half volt scale. That's 1, 2, 3, 4, 5. That's about 2.5 volts peak to peak right there of a peak reading. Now what I'm going to do, and I'm using the demodulation probe on the plate of the tube that's after the IF. The input is using this matching pad, 75 ohms, to the grid of the tube that precedes the IF. Now I'm going to do some tuning. I'm going to show you what happens to the amplitude of that when I center the 10.7 megahertz marker over it. So just keep an eye on that and watch this. Now I'm going to tune both cores, top and bottom, and see if I can move that over. Get this right. Using the K-Tron tool. Here we go. Wrong way. There it goes. So I'm moving, that's the top core I moved over. Now I'm going to move the bottom core over. I'll go back and forth with this a couple times. See if I can make that look any better. This is what always happens. I get this like little fat hump over here, not to mention losing a lot of gain. And I just don't know what I'm doing wrong here, why this happens. No matter what I do, so now I've gone down to 1, 2, maybe 3, so I'm at 1.5 volts. It's quite a drop over what I had. Anyway, that's the problem I'm running into, and it's this misshape here that I don't understand why this lumps out like that. And this looks nice. Just for the heck of it, I'm going to switch the matching pad to the 300. Oh, isn't that nice? So I'm wondering if it may have something to do with the signal that I'm sending to it through this matching pad is somehow fouling up the works. Because clearly it looks even like a worse situation with the 300 than when I had it at 75 ohm. So maybe the real problem isn't what I'm doing here, but it's something to do with some kind of tuning of this matching pad. I don't know, but that's the problem I'm fighting. Okay, the only difference I did here, besides I had to increase the power a little bit, is I switched to a ungrounded tube shield over the tube that preceded that. So instead of making a direct connection to the grid, this is coupling through the plate. So clearly I don't know enough about how this stuff works to understand what's going on, but that's the pattern now. I'm going to tune this up a little bit and see what it looks using this method. I figured maybe I was doing something to the tube with the direct connection to the grid, screwing up its gain somehow. Anyway, this is where I am now. I'm going to retune it and see what it looks like. Okay, what happened in that last one with that dip in the middle had something to do, I'm assuming, with the local oscillator. I pulled the oscillator tube out. It must have been hitting some kind of a beat frequency against the local oscillator. I'm not sure what was happening. Anyway, I pulled the local oscillator and I'm in the same boat, connecting up, coupling through the plate. I get the peak right there, and I can retune this so that the marker's in the peak, but it cuts the gain about in half. Okay, this is the best I could get as far as centering the marker. It had the same results where this was skewed over this way. The marker was on the left side. What this is, again, I'm trying to eliminate as many issues with loading of the tube and probe loads, all that kind of stuff. So what I'm doing now is I have, let me get the light on here so you can see it. I have the input, excuse me, here. That's to the tube that precedes this can. Right there is the can, and then I have another tube shield with the probe on the tube after the can. So there's no direct connection to anything. This is just capacitance coupling through the tube itself, and clearly I had to go to 5 microvolts even to pick this up. But again, that's about the best I can get as far as centering. There's no way I could actually get it. Well, I'll show you what happens. Here's me trying to improve that. You see, it gets lopsided. It gets gains in amplitude, but it gets extremely lopsided. As you see, it pegs it when I get off the mark. If I go off the mark on the bottom, that was a top adjustment. We're going to adjust the bottom. Obviously crank the voltage down. You can see the difference. Now it's right down there in the same spot. So no matter what I do, it's always about the same thing. It's way down on the bottom of the curve. So we're going to, I'm going to put it back in the middle just to turn the radio on and see how it sounds. And one of my things I'm trying to get here is getting a good, the radio's got good sensitivity, but I lack multiplex lock. And I'm trying to improve that. I've already tuned up the 19 kilohertz transformers. I don't think it's a multiplex. I think it's a signal that's getting to it. When I've scoped it, you can see the pilot tone kicking in, going out, and it's like it's just not quite working right. Anyway, I'm going to tune this back into the middle because I think that's where it's supposed to be, regardless of the gain I'm seeing here. It's in the wrong spot. I'm tempted to tune the whole darn radio to something other than 10.7 and see if I can just find out what frequency it's peaking at here and tune the intermediate frequency to that. But it doesn't seem like you should have to do that, so I don't really understand what's going on. Okay, I'm going to go back to basics now. Now I'm going back to the Fisher recommended setup. I've got it right at 5 volts. They say it's negative 5 volts. I'm using my HP 410 VTVM attached to the test point. You can't really see it, but it's right in there. And I'm using a heat kit, using the marker. It's not sweeping, just a marker. I verified just with a frequency counter that it is right at 10.7. And I've gone through and I've tweaked all the cores to get this voltage maximum. I've got the output level fairly set low on the marker. It says keep it below 5 volts. So what I'm going to do now is let this, see how stable this is at 5 volts. Then I'm going to turn it all off, turn it on again, and see if it still stays at 5 volts. My goal here is I'm going to put the old transformer, which I took out of this set that I was having problems with. That would be this one right here. This is the one that I took apart in one of the earlier videos. See it here. Put some epoxy in there to secure this. These tabs are a little bit too loose. I've set those cores in what I presume to be the midpoint range based on the threads that are on the side of this thing. And I'm going to try a variety of caps. I'm going to start off with 33s, which I think is what I originally used. Actually, I think I'll probably go with 39s or 37s because I seem to recall those kept these cores in their relative location where they are now, which also happens to coincide with the existing transformer. So I'm assuming these things were designed to have those slugs pretty much in the middle, centered up right on those threads. And I'm going to compare the performance of this transformer to the donor transformer that came out of a cheap FM tube set. I mean, I don't know if there's any difference, but my main objective here is to see if I can improve upon this 5 volts at that setting, which is, you can see right there, kind of pointing just a little bit below the off line. But I don't intend to touch this red knob, so I want everything to cool off. I'm going to turn it back on and see if I can reproduce these results. If I can, then I feel I can go ahead and swap these transformers again and see if there's any performance improvement.